let's discuss differences between ordinary annuity and annuity due. An ordinary annuity applies to cases where payments are made at the end of a period. These are annuities that we've been doing so far. If you check all the annuities that we dealt with, the payments or the installments were done at the end of the period, like at the end of the month. Okay, but if the payments are made at the beginning of a period, it is called an annuity due, like when the payments are done at the beginning of the month. So how are these two different? Let's look at these examples. Let's start with the ordinary annuity. Right, 500 Rand is deposited at the end of every month for 4 months. Calculate the amount that will be in the account at the end of 4 months if the account earns an interest of 10% per annum compounded monthly. Let's try to put this on a timeline. The payments are done when? At the end of every month. So this is the first month. So this means the beginning of the first month, then end of the first month, beginning of month 2. End of month 2, beginning of month 3. End of month 3, beginning of month 4. And then end of month 4, like that. So this is the first month, second month, third month, and fourth month. And then the payments are done at the end of what? Of every month for 4 months. Then here, that's where we have our future value. Okay, this is what we've been doing. The formula that we use for this will be f is equal to x, and then 1 plus I to the power n minus 1 over I. Okay, but now when it's annuity due, look at this example. It says 500 Rand is deposited at the beginning of every month for 4 months. Calculate the amount that will be in the account at the end of 4 months if the account earns an interest of 10% per annum compounded monthly. When the payments are done at the beginning of every month, it will be like this for 4 months. It will be like this. You see that? We say this is the beginning of first month, then end of first month, beginning of month 2, end of month 2, beginning of month 3, and then end of month 3, beginning of month 4. But now we're saying what will be the amount here. When you're using the future value formula, when you're using this formula here, if you're using this formula, it means we're going to get our future value here at the what? At the end of the third month or beginning of what? Beginning of the fourth month, isn't it? So what should we do here? We have to get the future value here, and then this amount is like it will gain interest for another month. So the formula slightly changes. It becomes our future value becomes x, then 1 plus I to the power n minus 1 over I, like this. Then this whole thing is like invested for another period, like in this case it's a month, so it's going to be invested for a month. So this is coming from the formula A is equal to P 1 plus I to the power n. Since n is just 1, we don't usually write 1 as an exponent, so we leave it as it is. This whole thing is like the P. Okay, so we calculate our future value here, and then it stays in the bank for 1 month, so it's going to gain interest for 1 month. So this is the difference between the ordinary annuity and the annuity due. When it's annuity due, you can what? You can find this, and then after that, just invest the money for the next period. Okay, and then the formula slightly changes and becomes this. Or you can do it one by one. You do this part first, get the amount, and then invest the amount for the next period, in this case for the next month. Let's do our calculations. So now for the ordinary annuity is going to be f is equal to 500, and then 1 plus 0.1 over 12 to the power 4, the number of payments, and then minus 1, all this over 0.1 over 12. And then what you get? F is equal to 2025,139,178. Then F is equal to 2025,14, or just 14 cents. Okay, when we do the annuity due here, there's still 4 payments, so it's going to be F is equal to 500, then 1 plus 0.1 over 12 to the power 4 minus 1, right, like this, or this over 0.1 over 12. And then this whole thing is invested for another month. There will be 1 plus 0,1 over 12 like this. Then put this in the calculator. You get that F is equal to 2042,015,338, which is roughly 2042,02 like that. This is the difference between annuity due and ordinary annuity. So we're going to do more examples in the next lesson.